problem, we are to take each of the following expressions and simplify them by putting them in a plus bi form. So it turns out whenever you take a complex number and you square it, or you take two complex numbers and you multiply them, subtract them, or add them, that the result is another complex number, and it can always be put in a plus bi form. So if you don't know the definition of I, here it is. It's defined to be the square root of -1. And you may have had an instructor that then argued what I squared is, that I squared would be nothing more than I times I, which would be nothing more than the square root of -1 times the square root of -1, which would then be that you have the square root of -1 squared, and then because you're squaring a square root, this would simplify down to be nothing more than -1. So if you follow that logic, then one of the things you may have been told about complex numbers and the imaginary number I is that I is the square root of -1, and that the imaginary number I squared would be -1. So it's sort of just taken on face value that you know those definitions. It's simply by definition that we equate this as the letter I. So here we've done the first one. I squared is indeed -1. In this example, since you have negative I squared, if I copied the negative, and then where I see I squared, I could think of that as -1. So I just made a substitution. I squared is -1, but there was already a negative in front. So you have negative -1, which comes out to be +1. And then down in this example, it would be 3i times 5 is 15i. And that when you do the distributive property here, it would be 3 times -2 is -6. And be careful here, you have I times I, which is I squared. And then this is not in a plus bi form. In fact, I forgot to argue that these were in plus bi form. So let me go back. This part was in a plus bi form because we can actually think of the b being 0. In fact, you could argue that the number -1 can be thought of -1 plus 0i. And 0 times anything is 0. This would get dropped out and you'd have the number -1. Same thing here. The number 1 can be thought of as 1 plus 0i, and a would be 1 and b would be 0. If interested, a is called the real part of the complex number. Then the b is called the imaginary part. So it may be surprising to you that the number 1, even though it does not look like a complex number, it is. It's a complex number where the imaginary part is just 0. So going back down here, I can argue now that this is not complete because it's not in the form a plus bi. So I have to take the I squared here and substitute it with -1. Doing so, I'd have 15i. I have subtract 6, and then replacing I squared with its equivalent value, -1, I have that this would be 15i, and then I have -6 times -1 is +6, and basically I'm going to leave that as my answer because I'm going to argue that I have put it in a plus bi form, or in this case, since I've written it this way, it's bi plus a form. So if you want, you could write this as 6 plus 15i if it satisfies your desire to have the a before the b. So that would be the complex number 6 plus 15i. My real part a is 6, my imaginary part b is 15. Moving on to the next question, realize that we changed the operator from multiplication to subtraction. Or you can think of it as you're distributing a -1, in which case you're thinking of that operator as multiplication. Either way, you are going to have 3 plus I. In fact, if you want, you could think of there's a +1 out here and you're distributing it and it changes nothing. Because when you multiply by 1 in mathematics, nothing changes. So you have 3 and then you have a +I. The parentheses weren't necessary. Here you can think of it as you're distributing a -1, or students often think just change all the signs in the parentheses because that's exactly what happens when you multiply by -1. -1 times 2 is -2, and -1 times -3i would be +3i. And then we combine like terms. We have a 3 and a subtract 2, which is 1. We have a 1i and we add 3i and you would get 4i, and I'm going to stop there because that would be in a plus bi form, right? 1 plus 4i is a complex number for which the real part A is 1 and the imaginary part B is 4. The last problem is going to look like a foiling problem. So if I was to FOIL, or I like to think of it as I'm distributing twice, 3 times 2 is 6. 3 getting multiplied by negative 3i would be positive times a negative is a negative. 3 times 3i is 9i. And then this times this would be I times 2, but we typically write that as 2i. And then finally, a positive times a negative is a negative, and 3i multiplied by an I gives you 3i squared. And you could simplify a little bit because we have some like terms here. This would be 6. You have subtract 9i, you have adding 2i, that combines as subtract 7i. And it would technically not be completely simplified if left in this form, because my ultimate goal is to be able to write my answer in a plus bi form, which can only be accomplished again by using this property here, that when I see I squared, I can substitute it with the value of negative 1. So doing that, we have 6, subtract 7i, and we have subtract 3, and where I have I squared right here, I'm going to be replacing it with negative 1. So moving along here, I would now say that this is negative 3 times negative 1, which is positive 3. And now I have I to no higher power than 1, which is what is asked in the question. I can only be raised to the first power. If it's ever being raised to the second, make the substitution. So here we have 6 plus 3 is 9, and you're left with 9 minus 7i. And again, that is in a plus bi form, where my real part A is 9, and my imaginary part B, the coefficient on I, is negative 7. So if you want, A would be 9. My imaginary part B would be negative 7. We box that answer, and that's basically it for this one.